Welcome to Class 10 Insight. In today's class, we shall be discussing about the important numericals from your examination point of view. So here is the first numerical. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So we are supposed to find the electric charge. So we are supposed to find the electric charge. Before solving any numerical, first let us write the given parameters. It is current that is given in 0.5 amperes. Next is time that is given as 10 minutes. Then we are supposed to find charge. What is the symbol for charge? It is Q. Its SI unit is coulomb. So which is the formula which relates these three parameters? That is Q is equal to I into T. Do we know I? Yes. Do we know T? Yes, we can substitute. But before substituting, we should observe whether the given parameters are in its SI unit. Yes, of course, current is in its SI unit ampere. Check whether the given time is in SI unit. No. So we have to convert it into into SI unit, that is to seconds. So 10 minutes, if at all we have to convert it into seconds, multiply it by 60. So what will be the answer? It is 6 followed by 2 zeros, 600 seconds. Now we can substitute. What is I? It is 0.5. What is time? It is 600. On multiplying, we get that 5 6 are 30 followed by 2 zeros. Since we have decimal point after one digit, so we also shift the decimal point to the right side. So we will be getting the answer as 300. What is the SI unit for charge? It is coulomb. Hope this numerical is clear. Coming to the next problem. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt? We are supposed to find the work done. So we have to find out the work done. First let us write the given parameters. It is charge that is given as 2 coulombs and it is the potential difference given as 12 volt. Which is the equation or the formula that relates these three parameters? That is W is equal to V into Q. In place of V I will substitute 12. Then in place of Q I substitute 2. Since both the parameters are in the SI unit, I can substitute them directly. So 12 2s are 24. What is the unit of work done? It is 24 joules. Hope this numerical is clear. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistances are connected in series to a 6 volt battery. Calculate the total resistance of the circuit, the current through the circuit, and the potential difference across the electric lamp and the conductor separately. So before solving the problem, first let us write the given parameters. So we know the resistance of the electric lamp. What is the resistance of the electric lamp? They have given it is 20 ohm. Then the resistance of the conductor. What is the resistance of the conductor they have given? It is 4 ohms. So what is the total resistance? Since they are connected in series, we know the formula for effective resistance in the circuit when they are connected in series. It is Rs is equal to R1 plus R2. What is R1 value? Let us consider it as electric lamp. Then it is 20. What is the resistance of the conductor? It is 4. So hence what is the effective resistance? It is 24 ohm. So this is the total resistance or the effective resistance in the circuit. So this is the answer for sub question A. Now coming to sub question B. What is the current through the circuit? What is the formula where we use to find the current? That is Ohm's law, V is equal to I into R. Do we know the voltage? Yes. Do we know the current? That is the effective resistance that are connected in series? Yes. So since we have to find out the current, keep it in RHS. Taking R to LHS, it becomes divided by. So what is the value of V that is being given here? It is 6. What is the effective resistance? It is 24. It is 6 ones are 6 fours are. What is 1 by 4? It is nothing but 0.25 ampere. So what is the current through this circuit? in which lamp and the electric conductor are connected in series, that is 0.25 amperes. Now coming to the sub question C. So we are supposed to find the potential difference across the conductor and also across the lamp. So to find the potential difference across the electric lamp, first we shall find the potential difference across the electric lamp. So using the Ohm's law formula again, V is equal to I into R. We have to find out V itself. What is the flow of current? That is 0.25 ampere. Then what is the resistance of the electric lamp as given in the question? It is 20 ohm. So you have to multiply 0.25 with 20. So 25 twos are, it is 50. We have one zero here, same zero. After two decimal points, we have decimal. After two digits, I have the decimal point. So I will also be shifting it after two digits. So the answer is 5 volt. So this is the voltage across the electric lamp. In the same way, how to find the potential difference across the conductor whose resistance is 4 ohm. So now we will be finding the potential difference across the conductor. Using the same formula, Ohm's law, that is V is equal to I into R, we need to find out V. What is the value of I here again for the conductor? It is 0.25. Why are we taking the same value of 0.25 ampere is because in series the value of current will be same through all the components. Now here according to the question we have lamp and a conductor that are connected in series. They have given the resistance value also. So here it is 20 ohm and for the conductor it is 4 ohm. I agree, definitely the resistance value is different. In series, what happens? The same amount of current flows through the circuit. Hence, in both the cases, we will be taking the value of I as 0.25 ampere. This is very important step. Many children tend to forget this step. So in place of R, what is the resistance of the conductor as given in the question? It is 4 ohm. So we will take it as 4. 0.25 into 4. So 25 fours is 100. After two digits, we have the decimal point. So we will also shift here. So we will get the answer as 1.00. That is nothing but 1 volt. So what is the potential difference across the conductor? It is 1 volt. So don't forget this point where we will take 0.25 in both the cases because current is same in a series circuit. A wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of same material having length L by 2 and area of cross section 2A? What have they given? They have given us the resistance value of the wire whose length is L and area of cross section is A. We are supposed to find the resistance value for another wire whose length will change to, which was L will change to L by 2 and area of cross section that was A will change to 2A. So this is the outline of the problem. First let us write down the given parameters. So for the first wire, what is the resistance they have given? Let us take it as R1. We know that R1 is 4 ohm. We also know the formula for resistance, that is R is equal to rho into L by A. Rho into L by A. So what is the value of R they have given? 4 ohm. So we can write that 4 is equal to rho into L by A. Let us keep this as equation 1. Now coming to the second wire, we are supposed to find its resistance using the same formula, for which what is the length of the conductor they have given? Earlier it was L, now it is L by 2. And what is the area of cross section they have given? It is 2A. So using this general formula R is equal to rho into L by A, in place of L I will substitute L by 2 because for the second wire the length is changing to L by 2 and area of cross section is changing to 2a. That is equal to rho into L by 2 by a. On simplifying, I take it to the numerator. 2 by a we will have to take the reciprocal, that is 1 by 2a. That is equal to rho into L by 4a. So R2 is equal to, I will split it and write it as rho into L by a into 1 by 4. I have just split it in this way so that I can substitute this equation 1 here. So what is equation 1? Value of resistance of the first wire, that is rho into L by a is equal to 4. So in place of rho into L by a, I can substitute 4. It is the resistance of the first wire into 1 by 4 remaining as it is. 4 and 4 gets cancelled. We are left with 1. So what is the resistance of the new wire? It is 1 ohm, whose length was L by 2 and area of cross section was 2a. Hope this problem is clear.